All right, so let me share the screen so I can see my board. All right, so it should be showing my board back there. Okay. I don't know where to put it. Oh, this stuff, my good marker. Oh, well. Right back, oops. All right, so they're all in. So I'll probably just use this one board so that they can watch us do this, okay? All right, y'all, so we're getting into chapter 5C. We're trying to get into 5C. All right, you see that on the board, right? All right. So, y'all, this is about statistical tables and graphs. All right, so the first part of this will be a few definitions. So we can get y'all familiar with data types and binning. All right, so I have to keep admitting people. All right, so data types and binning. So there's two main data types, y'all. We got qualitative data and quantitative data. So here we go, qualitative. All right, so qualitative data consists of values that can be placed into non-numerical categories. So consists of values that can be placed into non-numerical categories. So they're talking about colors of stuff, red's a color, blue's a color. Although it separates things, it's the qualitative data. It don't give me no numerical value, okay? What else? Like movie ratings. You know, they rate a movie 1 to 5 or something. That's also qualitative because it's an opinion and it's not really a numerical value. Although it uses numbers, it's still just off your opinion, okay? So, what else we got? I'll show you an example in a second, like brand names of shoes, Nike, Puma, all those. Those are what we would call qualitative data, okay? They sort of describe your data, but it don't have no meaning as far as numbers go, okay? Quantitative data all right, got another one coming in. Whew. I might have to pull that off. I'm back far enough, am I? Mm-hmm. All righty. Whew. Quantitative data represents counts or measurements. So y'all just watched all them basketball finals, some of y'all. So points per game, assists per game, all that would be quantitative because it's dealing with numbers on those, okay? Y'all ever found your test averages? Added all your tests up and then divided by how many you had to get your average, you're finding quantitative data for that, okay? So anything that has to be counted or measured, we're going to call quantitative, okay? All right, then we say this. So when dealing with quantitative data categories, it is often useful to group them or bin. So grouping is what they call the binning part of this. Or bin the data into categories. He's getting one, must be getting knocked off every time. The data into categories that cover a range of possible values. So categories that cover a range of possible values. So like on basketball, the assist. The range I'd probably put my assist in would be maybe 0 to 20. That'd probably be a fair range on those, right? Seldomly you get someone with more than 20 assists in a game, right? Might happen. That happens, we call them outliers. They're outside our normal data, okay? Alrighty, so bin just means they was just putting stuff together. Y'all heard of storage bins. You put all your stuff in the storage bin, right? Alrighty. So I'm going to show y'all some examples and we'll figure out if they want to be quantitative or qualitative. So quantitative or qualitative. So I sort of gave y'all this one, but brand names of shoes in a consumer survey. So brand names of shoes. So the question is, do you measure stuff for brand names? Because for this to be quantitative, it's got to have some kind of counts or measurements, right? Quantitative basically just describes stuff. So brand names are just telling me who made the shoes, basically. It's not giving me any data to compare anything. So this would definitely be quantitative. There you go. Okay. All right, so let me pick you up on this one. Oh, where did you go? All right, how about this one? So that was my number one. Test averages of all, what are we, math reasoning? So all math reasoning students. So test averages, would that be qualitative or quantitative? Because yeah, now I'm dealing with some kind of count or measurement. We're measuring their averages.
I thought number one, okay, one is quantitative too. Well, it should have been qualitative. Number one?
This one, oh, we said qualitative, didn't we?
Qualitative.
I was wondering.
I kept saying, because I said, I didn't.
Hey, y'all online, that's qualitative number one. I think I said it, but we wrote something different, so I do that sometimes. If you see me in college algebra, I'm doing something, I'm telling them, okay, 518, and I might write something different. They don't say nothing until like, I'm on another problem mode. Well, how did this turn to this? Well, it didn't. So this one was definitely going to be the qualitative. That's why y'all was all looking sort of funny out there, right? All right, so it's definitely, so colors, brands, colors, all that kind of stuff would be a qualitative, okay? Yeah, I must do that a lot. I'm trying to keep up with this, y'all. All right, so looks like we're about to make it past 15 minutes tonight, okay? The last 2 nights I did Zoom, it shut down on me. So how about these frequency tables? So this will give y'all a little math to do, I guess. So your basic frequency table has 2 columns. Okay, 2 columns. The first column gives all the categories of data. Second column lists the frequency of each category. This one gives the frequency of each category. So basically what they're saying, say I was looking at student grades in my class and I had it separated into A, B, C, D, and F. Those would be my categories. The frequency is how many of each did I get, okay? So if I was doing grades, I would have a grade category for my A, my B, C, D, and F, right? Then the second category, the frequency, is basically how many of each did I have? How many A's did I have? How many B's, and so on, okay? And we'll make one of these in just a little bit, okay? We just got to learn a few things. How to find the relative frequency. So this will be the fraction or percentage of the data values that fall in that category. So the data values that fall in that category. So to find our relative frequency, we're going to use this formula where your relative frequency is going to equal the frequency of that category. So the frequency of the category which they mean all your A's. I'm going to take all my A's and I'm going to divide by the total frequency, which is the total number of test grades I had or whatever, okay? So this would be the total frequency. Oh, good, look what I found. I'm lost without it, man. I can't write without my, for some reason, but here we go. So we'll have a chart, we'll have the category in the first column, we'll put the relative frequency in the second column, and then we'll find what we call the cumulative frequency. So let's write that one down. Let me see how to spell that. Cumulative frequency. So what this is the number of data in a category and all preceding categories. So the number of data in a category and all preceding categories. Now, when you're done with your overall cumulative frequencies, it's got to equal the number of total frequencies that you had. So if you had 20 tests that you were looking at, so many A's, B's, and C's and so on, we're going to find our relative frequency, and then the cumulative frequency adds each row. So you had 5 A's, so it'd be 5 here. Say the next one you had 4 B's, the frequency will be whatever that gives us, but the cumulative will be the 5 plus 4, which will be 9 at this point. And you just keep adding the next row's frequency until you're done. And remember, that's got to add up to the same thing as the total frequency that you had, okay? Also, the frequencies, when we figure out these percentages, they have to equal 100%, okay? Because everybody's got to be listed on those frequencies, okay? So, let me write a data table up here. And we're actually going to work this, all right? So here's your data. I got 20 scores up here. My 20 scores are 76, 80, 78, 76, 94, 75, 98, 77, 84, 88, and then my next row, I got 81, 72, 91, 72, 74, 86, 79, 88, 72, and 75. So the categories, they're going to list as scores, okay? So my categories will be the scores. I'll figure out the frequency. We'll figure out the relative frequency. Basically, we'll turn these frequencies into percents, okay? So that'll be my relative frequency. And then we're going to figure out the cumulative. So the cumulative frequency. So when we're done, relative frequency, all those should add up to 100%. Cumulative frequency, the last frequency should equal the total number of, so it should equal 20 when I'm done with that, okay? Because that's how many tests I've looked at, how many scores. And these frequencies, you'll see that they equal 1 if you added all them up. Because these are going to be decimal forms, and these are going to be the percent form, okay? So the way we're gonna break them down, we're gonna look at scores between 95 and 99, 90 to 94, 85 to 89, 80 to 84, 75 to 79, 70 to 74, okay? So they're making the categories, looks like about 5 units wide on each of these, okay? And that's what they was talking about, binning them. They're binning so many scores in that range, so many scores in that range, and so on, okay? So what we want to do is count how many of them scores are between 95 and 99. So let's see, want to say 95? So I got one here.
First. What about 95? It's two.
Just one.
Oh, just one, just 98.
Yeah, that's 98, right? So I had,
So it's two.
Oh.
I say
No,
94.
it's one. And I
Right,
was
one, it's
94.
one.
oh, just one, because it's got to be 95 or bigger.
Yeah, 98. It's just
So that was one, right? So now, to get my frequency, my relative frequency, I'm going to take that one and divide it by how many I had. 20. So let me pop out a calculator. So you're going to do 1 divided by 20. That gives me 0.05, and I'm going to turn that into a decimal. So let me write what I started. I got 0.05, and we know that equals 5%, okay? So how many, and now the relative frequency is how many times it happened was once. So now how many scores do I got between 90 and 94? So I got a 94 here. I got a 91.
2.
And that's it, right? 2. So do 2 divided by 20 now. And y'all should get, what, a 0.1? So turning that into percent, that's going to equal 10%. So now, watch this. The cumulative frequency takes this 1, adds that 2 to it, and now altogether, you see it's counting the frequency here plus the previous frequency. Okay? So now, how many scores between 85, 89? You'll see what, 3? Right, here's 1. 86, and then the 88. So 3 of them all together. So we need to do 3 divided by 20. So that should be what, a 0.15? That'd be 15%. So here's the question. Who wants to tell me the next cumulative frequency? 6, because you're going to add this 3 to the 3 we had, and I'm now accumulated up to 6 of them, okay? All right, so 3 more to go. 80 to 84. Three again? How many y'all getting? 3. And I had that one, this one, and that one, okay? So 3 of those, which I know is what, a 0.15, 15%. But now, what's the cumulative frequency at this point? 9. So you took the 6, added the 3 to it, got the 9. This ain't bad, is it? You're just making up tables is basically what you're doing. All right, 75 to 79, I got 1, 2, 3, 4, 5, 6, 7 of them, right? So 7 divided by 20. So that's what, 35%. Cumulative frequency at that point? 16? So y'all check this out. I've used 16 of my datas out of 20, so I know these has got to be 4 of them, right? The last 4 got to be that. And here we go. What must be down here? 1, 2, 3, 4. It's all on the second row, right? So 4 divided by 20. That's me what, a 0.20? 20%. And the cumulative is 20. So this cannot be higher than how many tests you had. And if you add all these percents, 20 plus 35 is 55, plus 15 is 70, 15 is 85, 95, 100. So it's got to equal that 100%. Or if you added all the decimals up, you get 1.0, which is 100%, okay? So not too bad, was it? So y'all gonna get to do one of them in homework, I'm sure. Oh, y'all, then I'll talk about bar and pie graphs. Now this is getting you broke in for my stats, because in chapter 6, we start doing the mean, median, mode, and all that fun stuff, okay? All right, so a bar chart. It shows the categories, and a bar shows its frequencies. So to use the bar on the bar chart to say how much of the frequency or how many times it happened, okay? So it shows each category with a bar. Whose length corresponds to its frequency or relative frequency. Corresponds to its frequency or relative frequency. Okay, so I'm going to sort of try to draw one of these real quick. So if we was to do one off of the data I had, on the bottom I would list those categories. Okay, so on the bottom I would list my categories. I had what, 95 to 99, 90 to 94, 85 to 89, 80 to 84, 75 to 79, and then finally I had 70 to 74. Okay, so it would use a bar to limit the frequencies. So notice the highest frequency I had was a 7. So over here I would have a 1, 2, 3, 4, 5, 6, 7, 8, 9. I might go to 10 on that, okay? So over here, it would say the frequencies. Because that's what I'm looking at on these. So for 95 to 99, my bar would come up about right there, right? Comes up to the 1 and it's going to stop. 90 to 94, my bar would come up to the 2. 85, 89, my bar would come up to a 3. Oh, what's next? Same thing on 80, 84 would be a 3. Now they're prettier on paper than I'm doing them. Next I had 7. So this one would shoot way up here to 7. And then finally I had 4 on the last one. We've all seen them charts before. The main thing, just remember, it's measured on this one frequencies. So the height of these bars will correspond to those numbers on the side, okay? And a lot of times they'll have little lines sort of faded out lines on it so that you can tell right where you're going to on those. Okay. Well, that's one use of a bar graph. Now I could have put my frequencies here and made this from 0 to 100%, right? And then my bars would have still been about the average same heights. Okay. So what is a pie chart? Y'all seen them? Alrighty, so pie charts. So I will say the pie charts are more reserved for the relative frequencies. Okay. So primarily, for relative frequencies. And the total pi has to equal 100%. So the total pie chart has to equal 100%. The size of each piece or wedge is proportional to its relative frequency. Is proportional to its relative frequencies. So if you got one at 50%, it's taking half of that pie, right? Because 50% of something would be half of it. And then you might have pieces that were what, 25%, 10%. We even had one, I think, that was 5%. That's going to be a little bitty slice of that, okay? 1/20th of that pie, okay? So another thing that you can do on these when you're dealing with like 20 things, split it into 20 sections, and then for each one, you're going to color a section in of it, okay? Alrighty, so I'll make a table for this one and then show you the pie. It'd be better than doing ours, but I'll be close. So pie chart example. So they got data here with the grade and frequency. So A, B, C, D, F. And I got 4, 7, 9, 3, and 2. So this one had 25 students in it, okay? So a pie chart representing this, I'm going to try to draw this. Microsoft Excel does it a lot better. You just put your data in, tell it, hey, I want a pie chart, and boom, it kicks it all sliced up and everything. All right, so it looks like that. That's going to be the A's. Right here is going to be the F's. And then we're going to figure out our stuff in a second, okay? That's the D. Over here, this one, about right in there. That's the B's. And then what's left has to be the C's. So we're going to figure out what percents each of them should have. So you're going to take all these numbers and divide by 25.
25.
Yeah, because isn't it 25? So 4 divided by 25, let's see what that'll give us. 0.16 or 16%. That was my A's. The B's had 7, so 7 divided by 25 is 28, so that's going to be 28%. C's were 9, so 9 divided by 25 is 30.36, so it'll be 36%. All right, D's was what, 3 divided by 25? 0.12 or 12%. So 2 ways you can find the F. You can add all these up and subtract it from 100, or you can take that 2 and divide by 25. So 0.08 or 8%.
Now, you always have 5 slices or what do you?
No, I just had 5 slashes, because I had 5 grades. So if I only was counting, say, a developmental class that had the A, B, C, NC type grade, then I would only have 4 slices. And then they would be sized to what proportions I had out of my data. Okay. So it looks like most of them, if you look at the pie chart, most of them made a C, because that is the biggest chunk of pie, okay? So the B's and C's take up over half of my chart, though. Right, 36 and 28 is what, 64% of it was C's and B's. So the other 30-something% was A, F, and D's. So 20% of them failed the class, right, with a D or F, because you had the 8 and the 12, right? So that's basically what a pie chart is it's going to show relative frequencies, how many times things happen, okay? All right, questions on those? All right, so we're going to show you a few things that's important for graphs. So, important labels for graphs. Well, the first thing you want is a title or a caption. Now, I'll tell you, some of this stuff it's not going to hit you with in the homework. Mainly the homework was doing some of the frequency stuff and then determining if something was quantitative or qualitative and stuff. So they're not killing you with this info. But you want a title or caption to sort of show what the graph is even telling me. What information am I getting from that graph, okay? You need a vertical scale and title. So your vertical scale is the numbers going up and down vertically, like my frequencies when I was doing the one. So you want the numbers on the vertical axis should clearly indicate the scale, what you're using. Now, for big numbers, like if I wanted to look at the deficit of the U.S., I'm not going to write 31 trillion. I'll probably put it 31, but at the top of my scale, I'll say in trillions of dollars or in billions of dollars, so that you ain't got to write them big numbers, okay? And you can just keep it down to 1, 2, 3s and stuff like that, okay? So remember, this one's going to really show you the measurements, okay? Well, you definitely want that horizontal scale. And title for red. But we might be going by years down here, but I need to let people know I'm going by years, okay? You'll see graphs sometimes they'll say, hey, they'll start at 0, 1, but they'll tell you that 0 is starting at maybe 1990, and then you go 1 years after that or so. So they got to give you that information so that it all makes sense, okay? And then a legend. So what they mean is if you have more than one data set you're looking at, sometimes you'll see graphs use a red line for one data set, a blue line for another data set. If I was comparing maybe men and women, I might have the blue bars for the women and the red bars for the men. And I'll compare that on each of my grades. So this could be like color coding or other means to distinguish between different data sets. Yeah, I might be looking at how people are going to vote for this election. I might compare who's blue. Red is one and blue. Red is Democrats or Republican. They call us blue states, red states, whatever they talk about. But I might want to compare how they're voting in each party for the president. Okay? So I can break it down and compare my Republicans versus my Democrats. And if I even had more data sets, what are they? Libertarian and Green Party, and there's even a Communist Party I've seen, and all kinds if you look at them. So I could use many colors if I had to, okay? But y'all seen them where they stack the bars like a blue bar and a red bar and a green bar, then a red bar, green bar, blue bar for the next set, okay? So, have y'all heard of a histogram? And it's a bar graph for quantitative data. So bar graph for quantitative data categories. All right, so the bars have a natural order. And the bar widths have a specific meaning. Well, maybe I still got all 6 of them on there. All right. All righty, so I'm gonna try to draw this histogram for y'all. A little tricky. So on the bottom they got scores. So that'd be my bottom horizontal scale. And on the side we got frequency. Once again, that goes up to 8. So it's going to start at 0 and go to 8. All right, then let me see. These scores go from 70. I'm going to bring that down just a little. So they start at 70 and go up by 5s. So the difference between this and the one I drew a while ago, these ones usually are bars right next to each other, okay? So let's see, I'm going to go up to 4 here, and then it's going to come across and go down. So it's going up to 4. this goes up to 7 from that point. Then we got 2 we had at 3, remember? So 3 for this bracket, 3 for that bracket. Then from 90 to 95, I had 2. And then I had 1 at this range. So remember the bar I drew a while ago had each bar went to its frequency. This, they put the bars right next to each other and they break it into ranges here. Instead of doing 70, 75 and then 75, 80 like I was doing it a while ago, they just put all the numbers here. And the bar goes between 70 and 75 and it has a frequency of 4. So then the scores between 75 and 80 would use the second bar, and they had a frequency of 7. So the bars represent the ranges on this instead of you having to go in and specifically put every single range on there. But remember, I had to write a lot of 75, 80, 80, 85. Remember? So it's basically a histogram, okay? Oh, what was next on there? A line chart. I was going to be killing y'all with different types of charts. It shows the data values as a dot. So it shows data values as a dot. And the dots are connected with lines. All right, so I could do one of those. Let's see. So this would be for the same data I did on this one, okay? I'm going to do my scores on the bottom again. And I'm just mainly just showing y'all the differences between these types of, what was that on the side? Frequency again. And y'all use the same scale as that and from 0 to 8. And then my scores were in the same range, 75 to 8, 70 to 75. So I'm going to do 70, 75, 80, 85, 90, 95, 100. Now, watch how I put my dots. So the first range between 70 and 75 had 4. So I'm going to go in between these two and put a dot at the 4. So that I know it's in between 70 and 75 now have a value of 4, right? In between 75 and 80, I was up to 7. All right, 85 and 80, I had 4. Was that in 4 also? Yeah. Oh, hold on, these might have been 3s. Yeah, so I'm gonna move that down to a 3. This one was a 3. Then between 90 and 95 was a 2. And then between 95 and 100 was a 1. Now, I'm gonna connect all the dots and be done. So you start at 0 here, right? Oops, that one's more flat. There you go. It's just a dot in between the columns for each range you're looking at. Find that frequency, put that dot, and then you're just drawing the line, okay?
So do you always have to start at 0?
Yeah, they always start them down here in the corners. Now, actually, this would have something coming down like that, and probably going across like that to box that graph in. Okay. And they always start at this one because it's the 0 frequency. And then you're just going to, in each range, you're just seeing what their frequencies are and moving on, okay? The last one I want to look at is a time series graph. And what's nice is Excel, man, you can pick out which one of these you want. When you insert a chart, it'll ask you what type you're putting in. Bar graphs, pie charts. It'll even do a time series. And basically, it's just a line chart or histogram in which the horizontal axis is time. So a line chart or histogram in which the horizontal axis represents time. And you see them on TV all the time. Hell, the COVID stuff is pretty much one of those, ain't it? It's going day 1, day 2, day 3. And you're watching that spike up, come down, spike up again, and come down. So it's representing time on that. So that'd be more like a histogram with a time on it, okay? All right, so I probably won't draw one of them. They don't kill you off that, but it would be just like that stuff the governor's doing every day. All of those basically are time series type graphs, okay? Some are showing hospital rates, some were showing death rates, infection rates. All those are time series because he's looking at them on what's happening from day 1 to day whatever we're in now, okay? All righty, so I wanted to get this project out and see if y'all had any questions on it. Because the main thing you want to get started on is finding your dream car.
I did have a question about the stuff we, not about this, but the stuff that we have learned with the statistics and stuff. You said that we're not doing an exam on that, right?
Right.
Okay, so are you gonna show
So-
it again?
The only thing you'll see out of this is maybe a quiz or so, and a lot of it's out of the support stuff. We just want to expose you to this and let you play with it as homework, but they didn't feel like it was a subject we wanted to really test y'all on. So y'all will get a second test, but it's going to be more toward the end on like chapter 8 and 9, that kind of
I just
stuff.
wanna make sure the definitions weren't done up again.
No. All this, we're just giving y'all a little bit of taste of stats, I guess you could say. So that's what maybe 5 and 6 are. This one, we're almost out of 5 now. I think we got E left or something like that. Then next week we'll deal with the mean, median, mode stuff. We get into that kind of stats. But yeah, we're not gonna kill y'all on being tested on all that.
Okay. Are we turning this in paper?
Well, if you're in face-to-face, I'll take it paper. The ones online, I'm gonna try to set up a way they can submit them in Blackboard. I've never done that, so I'm gonna ask, what's your name, Ms. Riding? How do I set up it? Because I want it to go in the math lab first. And I'll grade it there, then I want it to trickle into the Blackboard.
What about email?
Well,
Yes.
no, I'm gonna have y'all submit it, I just
Okay, yeah,
don't.
I'm saying, I was curious, because I can email some of my.
Have y'all ever put stuff in Blackboard?
Yeah.
Yeah, I did.
You know how it's like an English teacher, you submit assignments in that,
Yeah.
and I'm gonna figure out how to do that.
Yeah.
And then what I'll do is when they come in, I'll look at them real quick, grade them, and then I'll be able to put them grades in. Because it'll say you submitted it, but it won't be graded until I actually look at it. Sort of like some of y'all teachers do on essays and stuff.
Yeah.
So y'all mess
Yeah.
with that?
And my Spanish stuff, I mean, we do all our stuff on another website, but all of our submission assignments, we do separate, like.
Okay.
Just
Right.
yeah.
Right. So yeah, I wanna do that, something like that, and, that'll be what that project stuff is considered in the grades and stuff. Okay. So the main thing at this point, I would try to have that car done, at least know what car you want. Mine's in Italy, by the way. Any cars that end with an I are probably from Italy. Lamborghinis, Maseratis, Ferraris, you know, all them nice little fun cars. I probably couldn't even pay the sales tax on one of them things on the car, y'all.
That's the thing.
You know what I mean?
And it, well, let's do, you get it there, give you the interest rate, is what you're gonna charge.
So I had it at the 25th, I think I'm gonna make this due November, look what the second Sunday in November was, it's like the 12th or 14th or something.
Sunday, November 8th.
Hey, okay, let me do that.
And then
11/8?
midterms are coming up, or mid-grade.
Well, midterms, I'm just putting in what y'all had so far in math class, so most of y'all had good grades.
Yeah.
I only had 2 people that were failing, and they were online people, and one I don't even know who the hell they were. They never tested or nothing, y'all, I don't know who they were, you know, so. All they did was that, remember that little quiz I had in the very beginning for the course agreement type stuff? They did that, which constituted them doing a graded assignment, so they got to be considered in the school, so they got their financial aid, and then they took off.
Hopefully they withdraw.
Some of them get that money and then they're gone, y'all, I ain't lying. So, you wanna choose your car, and then what you wanted to do was go to one of them websites I got on there, and just sort of punch in your car information on it and see what kind of value you had to pay for it. And we're just going off the blue book, we don't want it marked up and all that stuff, as you know, the dealers do mark them up.
Okay, now, I've never looked at it, but does Kelly Blue Book have a Bentley in it, a Bentley in it? I'm just saying,
Hell, I don't know,
I mean, I don't know, I'm just saying, would that be in the Kelly Blue Book together?
hopefully one of them does.
Yeah, I know.
I mean, it's a car,
Okay,
hell, how old is it, Bentley?
no, did you see the no?
Is that old, that's old though, ain't it?
No.
They make Bentleys now?
Oh, my God, yeah.
I was gonna pick the Rosewood Goat.
Oh, I was gonna say Rolls Royce. No, let me tell y'all this. My dad, when I was younger, he, was in the Air Force. I was up in Pennsylvania visiting one year. So he always went down and would drink at the little club. Well, there was a car salesman that was famous there one day. And, yeah, he actually met the dude. So do you know an ex-boxer that sold Rolls Royces for a little while? But then he got back into boxing again. And he was really good when he was in his days. How about it, Larry Holmes? Y'all remember him?
Oh, yeah.
Yeah, he did that after he got out of boxing, I guess, because he was from up there, I guess he was from Easton, Pennsylvania or something up there where my dad and them were at. But yeah,
Last person to beat Muhammad Ali.
yeah. But yeah, he was selling Rolls Royces or something like that. He might have owned it, I don't know. I don't know back then, y'all, but he's a pretty big dude actually when you see him. Like you're pretty big.
Mike Tyson knocked him out. Mike Tyson knocked him out.
Well, my guy was like 20 years younger. That's after Larry Holmes had to deal with the Jerry Cooney dudes and all them, remember?
Oh, yeah.
There you go,
So, okay.
21 GT,
Oh, that's pretty sweet.
that's 250,000, that one is. The other
I'm
one.
sure someone values this car somewhere. You might be going to the dealership for that value though, instead of the blue one.
Yeah,
I'm sure those don't get put on the common market.
oh, no.
Hey, I'm selling a Bentley, where's my rich buddy? You got a kid in a Bentley or something, you know?
Some old ones
Oh,
on
yeah,
that,
yeah,
like
yeah.
35,000.
Oh, yeah.
So how,
But yeah, that's like a 2008 or something like
It's in pretty good shape though.
Yeah, 2008 wouldn't be bad either.
that's like BMWs.
But still, upkeep is
Oh,
Yeah,
yeah.
I'll keep it
Yeah. Yep.
like $500 for a
Oil change.
All right, y'all, I'm gonna quit sharing my screen. All right, so any questions online? So y'all made it to a Zoom, actually. Did it go all right?
You were dragging a little bit.
Yeah, I'm hoping to get our internet totally fixed up here. But was my notes was y'all able to see my notes and stuff?
Yes.
Okay, so I'm gonna try to do this every class and hopefully they improve our internet for us, okay? Now, what I'll do, since I recorded this, I will send this video out later and then y'all give y'all a copy of it, okay?
Okay, good. Okay.
All right, y'all, so I will see y'all Thursday night.
All right.
Okay.
Thursday. Okay, thank you.